Hello, so these are the equations you're going to see on the homework. You're plotting the points and you're supposed to guess which polar equation goes with the points that you're plotting. So I just want to give you some hints on those. So first of all, if you have a cosine function, it always goes between plus and minus 1. Okay, so it ranges from -1 is less than equal to cosine theta is less than or equal to 1. So that part of the equation is going to oscillate between plus and minus 1, which means if I go out a layer, the second term is going to go between plus and minus 3 in that first equation. Okay, the first term is always 1. So this function, its radius is going to oscillate between 1 plus 3. Actually, let me do 1 minus 3 first, which is -2. Okay, and 1 plus 3, which is 4. So we're expecting -2 to be less than or equal to r, which will be less than or equal to 4. So this tells us a few things. First of all, we're expecting there to be some bubble that's going to go all the way out to a radius of 4. We're going to see a bubble because cosines fluctuate, or they cycle. So we're going to see some sort of lobe that goes all the way out to 4. But we're going to see a different lobe that goes to a radius of -2. That means it's a backwards bubble. Okay, so there's going to be a little backwards bubble of radius 2. The negative means it'll be going in the wrong direction, away from the angle instead of towards the angle. Whereas the 4 indicates that we will have a sort of forward bubble in the direction we're expecting it to be, of radius 4. Okay, now let's see, the equation that's most like it and the one that's easiest to maybe mistake for it is the one that we have over here. This is oscillating between plus and minus 1. Okay, and so we're going to have r values. You could have a 3 plus 1. Let me just do that here. Actually, let me do 3 minus 1 first as the smallest r value, which would be 2. 3 plus 1 would be the largest r value you could get with this 4. Notice everything's positive. So we're looking for something that never goes through the origin. We'll never have negative values to this. Okay, so it goes over here, never 0. Okay, so it'll go around, so it never passes through the origin. In polar coordinates, that's called the pole, ever through the pole. All right, and it's going to have a radius. The lowest possible radius will be 2, and the highest is 4. So we're expecting to see something that kind of undulates between a radius of 2 and 4. Okay, and it'll actually, at the angle 0, it'll start at 4. It will drop down to 2 and then go back to 4. So this is at 0. By the time we get to pi, we would expect a radius of 2. And by the time we get to 2 pi, it'll be back over to 4 again, and meet up with where it was at 0. So that's kind of what we would expect from that one. Moving down to these others, okay. This third one is just, this is going to be between plus and minus 1. So overall, this is going to fluctuate between plus and minus 4. Okay, once again, we could kind of lay out the numbers. When we're at an angle of 0, we'll be at 4. Okay, at some point, we'll drop down to 0. We'll go down to -4, back to 0 and 4 again. Okay, so this will pass through 0 as a cosine of 0. You could probably line these up somewhere around 0, pi over 2. Okay, pi, 3 pi over 2, and 2 pi. We would kind of expect something like that to happen for that function. Okay, now what's different on this next one is we have an argument of 3 theta for the cosine. So this means it's going to change faster. Okay, it will go through 3 as theta goes from 0 to 2 pi, okay, 3 theta is going to go from 0 to 6 pi. So we're going to get 3 cycles out of this. So it'll go from its biggest value to smallest to biggest, and repeat that 3 times. Okay, so we're going to see something that oscillates between plus and minus 4. Okay, so -4 is less than equal to r is less than equal to 4, but it's going to do this over 3 cycles. So we're going to expect to see a lot more lobes because it's going to cycle more times than the previous example, right? Then we get down to these last two. Going to be a little different here. This is going to be, once again, this is going to cycle 3 times. All right, so we're expecting a bunch of bumps. And we're going to have this back part is going to oscillate 3 times between plus and minus 3. So that means the R value can be as low as -2 and as high as 4. But we're going to expect to see more lobes because the cosine is going to cycle more times. Now, sometimes those cycles overlap each other, so the graph may not show them all, but as you're plotting a point in terms of the points, you'll see that you are cycling through things multiple times. All right. Last one is a little bit tricky. This is cosine squared. So it actually does not fluctuate between plus and minus 1 because we square it. -1s become 1. But this will range from 0 to 1. All right, it'll start at 1, go down to 0, but bounce back up to 1 again. Over the course. So think of what a cosine squared function would look like. It would never go negative. All the negative bumps would be positive, and the shape would change slightly. So that means this section is going from 0 to 3. Okay, which means that the R values are less than, 1 is the lowest we can go, because 1 plus 0 is less than equal to R is less than or equal to 4. So once again, the radius is never negative, so it will not pass through the middle, okay? Never passes through the origin or the pole. Okay, so you would expect, see something that's going between 1 and 4 in its radial size, and it's going to undulate a little bit faster because if you were to consider a cosine graph, it looks like this. If you square that out, all the negatives would become positive. The shape will change slightly, but it'll do something like that instead. So, so it looks like it'll drop and go up again, and never go in the negative direction. So hopefully that's helpful in identifying which graph, which plotting of points goes with which function. So I hope that was useful.